In the name of Allah, most gracious, most merciful. Hello everyone, welcome back to my math channel MathWeb. Let us start question number 6 from Pearson Edexcel A-level exam for Pure Math 2. Paper reference code is WMA 12/01. This exam is taken in May-June session year 2024. First part, sketch the curve with equation y equals to a to the power x plus 4, where a is a positive constant greater than 1. On your sketch, show the coordinates of the point of intersection of the curve with y-axis, the equation of asymptote. Before sketching this graph, you should know the standard graph for the exponential function. There are two types of the graph for exponential function. Let me draw both of them here quickly. You should memorize the standard graphs, okay, for all types of function: reciprocal, logarithmic, algebraic, trigonometric. Let me draw the graph for exponential function. There are two types. Let me draw both of them here quickly. X-axis, y-axis. Let's say this is an exponential function, and here a is greater than 0, greater than 1. This is the one case. As the value of x increases, value of y also increases. As the value of x decreases, value of y decreases, and it approaches to 0 but never touches this line. Let me use a different color here. Like with the increase of x values, this is x-axis and here is y-axis. This one is y-axis, and with the increase of x values, value of y also increases. It goes like this way. Okay, when x equals to 0, when you put this one equals to 0, x equals to 0, a to the power 0 will be 1 and y-intercept will be 1 here in this case. And with the negative x values, like value of x decreases, value of y also decreases. It will approaches to 0 but never crosses this line. Therefore this line is called line of the asymptote, horizontal asymptote, this one. Okay, this line, the x-axis line, this is the horizontal asymptote here. And equation of horizontal asymptote equals y equals to 0. Hopefully you understand how to sketch this one. So this is the one case. There is another case when a lies between 0 and 1. When a lies between 0 and 1. So what will be the shape of the graph? Let me draw this one as well here. So this is the second case when a to the power x and a is lying between 0 and 1. Got it? When value of a is between 0 and 1, like a fraction, like 1 over 2, 1 over 3, like that, 2 over 5, like this. When it lies between 0 and 1, then with the increase of x values, value of y decreases. It is opposite. Got it? And with the decrease in x value, value of y increases. It is opposite to that. So the graph looks like that. It is decreasing, approaches to this line, x-axis line, but never touches this line. Okay, still the y-intercept is 1. So these are two cases, two types of the graph for exponential function. Okay, hopefully you understand this one. In both cases y-intercept is 1, but these are the conditions. And here let me draw the equation of the horizontal asymptote here. Horizontal asymptote is the same line, this one, and equation of the horizontal asymptote will be y equals to 0. Got it? Now if you look at this function, now it is similar, but there is a transformation. Something is added to a to the power x, 4, and value of a is greater than 1. It is given here. So the shape of the graph looks like that, the first one. Therefore we will sketch now the same graph but transformed. There will be a transformation, the vertical transformation. It will go 4 units up, like 1 will move 4 units up here. You know, to get the y-intercept you can put x0, even in other words it will be 1 and plus 4. You know, a to the power 0 is 1, 1 plus 4 will be 5. So y-intercept will be 5 in that type. And same way this will be the line of asymptote. He is asking to you write the equation of asymptote there in the graph, because in that case equation of asymptote is y equals to 0. Now this line will move 4 units up, and the equation of asymptote will be y equals to 4. Hopefully you understand all of this sketch, how to sketch one and this one. Let me use this given space here. This is y-axis, x-axis, and then I will use the same shape like the first case. This is x-axis and here it is y-axis. Y-intercept will be 5, somewhere here it is 5. When x equals to 0, y is 5, and it goes like this way. Value of x, y increases with the increase of x values. Sorry, we can draw better than this. Yes, goes this way, and it will pass through this point 5 and like that. Got it? And there you need to draw the line of the asymptote, horizontal asymptote here. So horizontal asymptote will be here like this. The equation of this line of the asymptote will be y equals to 4. You know, this line is 4 here, 4, 5. In standard graph it is 0 and 1, but here there is a transformation, so it will be 4 here, because the line of asymptote moves 4 units up. Y equals to 4 is the equation of asymptote. You have to mention this one in the graph. Equation of asymptote. So this is all about the sketch. You have to write the equation of asymptote and the point of intersection at along y-axis. First part is done. For the next part, here the table shows the corresponding values of x and y for y equals to 2 to the power x minus 2x. With the value of y given to 4 decimal places as appropriate, use the trapezium rule with all the values of y in the given table. Obtain the estimate for integral limit is from 2 to 3.5, 2 to the power x minus 2x dx, giving your answer to 2 decimal places. So let me write a formula for you guys to find the area by using trapezium rule. Actually, integration is giving you the area under the curve. When you sketch the graph for this function, it looks like a trapezium from 2 to 3.5. This is called trapezium rule. You have to memorize the formula for this. That is equals to h by 2 y naught plus yn plus 2 times y1 plus y2 plus y3, and it continues, and the last one will be y. This is the second last value, yn minus 1. Let me tell you here, this one is in the table. This is y naught, the last value is yn, and what's about h? The middle values are y1, y2, y3, and this value will be yn minus 1. H is the length, strip width, because you will divide the area of the trapezium into the small segments. The length of each segment is called the strip width, and we could find that strip width by subtracting these two. Or you can subtract these two. You can subtract these two values or all of them. It should be same. 2.3 minus 2 will be 0.3. So you can find out this is h. This strip width will be equals to 0.3. Got it? Now plug in the values in this formula. Actually, you have to write in the given space below. Here I think you will understand better here, instead of writing the values again and again. So I am solving over here in this space, but during the exam you have to solve within the space given in the exam paper. H is 0.3, divide by 2. Now y naught is 0, yn is the last value, 4.3137, plus 2 times the values between them. This is y1, 0.3246, continues. So the next value is 0.8629 plus 1.6643 plus the last value, the second last value, this one is 2.7896. Then close the bracket of this one, and you have to close the overall bracket, the big one, square bracket over here. Finding the area of the trapezium, giving you the answer for this limit. Okay, actually this is the area, this is equals to area. and area will be equals to, after solving by using calculator, you get the answer 2.34. So this is the answer for the second part, B. A equals to 2.34. Now for the last part, using your answer to part B and making your method clear, estimate the limit from 2 to 3.5, 2 to the power x plus 2x dx. We found the answer for this limit, that is equals to 2.34. We will use this result in upcoming question parts here. We want to, for the first part, we want to find the integral from 2 to 3.5, 2 to the power x plus 2x dx. This is equals to, we will rewrite this one in such a way that we will get the previous expression like previous part. 2 to the power 3.5, in previous part it was given that 2 to the power x minus 2x. Because you are subtracting minus 2x, you are subtracting 2x from yourself, you have to add the same number here, 2x, and write this 2x again over there, dx. Why we are doing so? Because we already got the answer for this part. Rewrite like this, 2 to 3.5, and we can write as 2 to the power x minus 2x dx. It is exactly like part B. And solving these two will give you 4x. So it will be 4x here dx, and limit is 2 to 3.5. We already got the answer for this one in the last part, that is equals to 2.34. We'll replace this one by 2.34, and plus the integration of 4x is 4x square. We increase the power by 1 by power rule, so it will be 4x square divided by 2 by the same power. You know the rule. Here power is 1, we will increase the power by 1, so we get 2 and divide by the same power. So 3.5, and here is 2. Apply the limit there, you simplify, we get 2x square here. Now it will be 2.34 plus, apply the limit, you know how to apply the limit. 2x square means you will apply the upper limit here, 3.5 whole square, then minus 2 times x square, we will apply the lower limit. This minus is of formula, 2 square. Now simplifying within the bracket, the answer is 16.5. 2.34 plus 16.5, and the answer of this part will be equals to, this is 16.5 plus 2.34, give you the answer 18.84 to 2 decimal places. So this is the answer for the first part of C. This is the answer for the first part of C. Now for the second part, we need to find the integration of this function in 2 to the power x plus 1 minus 4x dx. Again we will do some kind of treatment. Let me, here is space, so I will utilize this space so you will understand better here. You can rewrite this one like this. Actually we want to make this function again, the similar function again here, from here. So it will be 2 to the limit is 2 to 3.5, and here you can write as 2 to the power x into 2. Because bases are same, you can add the power. We will split this 2 to the power x plus 1 into 2 to the power x into 2 to the power 1 minus 4x. In the next step, you know, here 2 is common between these two. 2 is common. You will keep this 2 outside of this. So it will be 2 to the power. So it will be integral, limit is 2 to 3.5, and here inside the bracket left with 2 to the power x minus 2x dx. It is exactly like in part B, this one, similar. You can see the answer of this one is 2.34. Therefore you will multiply 2 by 2.34 by its value. And finally the answer for the second part of C is 4.68. This is the answer for the second part of C. Question number 6 is done. If you have any question or suggestions, please write in the comment box. Thank you.